Good sound check. Oh, all right, guys. I think we should be good to go here. Yeah, no, that's cool. Okay. So as I mentioned before, I realized that as I went through the archives that I couldn't actually see the 2014 paper in the, well, what do I say? In the videos. So I kind of did this with the level threes for the last couple of streams. So what we did was like we did one question, and so we did like question one, and then we did like all the couple of excellence questions towards the end, and then after 1 hour, I kind of stopped the stream, and what I did was I recorded the rest of the videos later on in the night, and I uploaded it. So I'm wondering whether we do that again because off the top of my head, I just got a bit carried away with my own schoolwork, so I didn't have time to kind of like prep things. So how this whole kind of, and this is the first time I'm doing it with you guys with the level twos. So the way it works is I will kind of give you guys some time to do the question, and then when I'm actually explaining the question, I'll record it. During that time, I probably won't answer any questions, but then I'll pause the recording, but the stream will still be running, and then I'll open up the floor for like questions and so on. So hopefully that makes sense, but we'll give it a crack, yeah? Archie, congratulations, man. That's good stuff. Nice to hear that. Um, yeah, I guess now get ready for the what do you call it? The real exams. I think you'll be all right, man. What are we doing? Yeah, so let's kind of kick things off and let's get straight into this. Um, there is a clock at the bottom of the screen. You guys will see it. So I'm kind of using that clock at the moment to give you guys times and so on. So like normally I'd say, okay, for this question, you guys got about like a couple of minutes. So kind of like that, all right? So this is question one, and I'm going to give you guys 2 minutes to try and do this question. Of course, you're more than welcome to just throw the answers up in the chat once you get it. And I'll also go through, once I finish the recording, I'll go through like some of the things from the answer schedule as well. So have a go at this, and then at 8:04, I'll go through the answer for this question. Are we back yet? Are we back yet? Okay, we are back, but my sound is playing up. Can you guys hear me? Are we back yet? Yeah, it's the first time my computer. Cool, we are. It's weird because my computer's never crashed on me ever over 1.5 years of having this beautiful little machine. Um, just sometimes things happen, eh? All right, so I think you guys had enough time to kind of do that. It's probably the longest time I've given you guys to answer question 1A. But like I said, I'm going to start recording away. If it is a bit blurry, just I think if you change to a higher quality, it should be back to normal. Um, yeah, solid 10 minutes, longest 10 minutes for this achieved. Where are we at? Okay, so this is the part where I actually record this question. Once I've stopped the recording, I'll ask, I think you guys should be all right, but let's just go through it. Cool, so question 1, what we're doing is we've been given g of x, and all we are asked to find is the gradient of this graph at x equals to 2. So the way we're going to write it is, we kind of write it as g of 2. This is what I'm looking for. So to do that, I need to work out what g of x is first. So I need to differentiate this function that is x cubed minus 4x plus 5. So I'm going to get g of x is equal to 3x squared minus 4. And then I'm going to substitute 2 in there. So I'm going to get 3 times 2 squared minus 4, which is 12 take away 4, and it equals to 8. Now, a really quick thing for you guys is you can also do this in the calculator to just check your answer to see if you're on the right track. So what you do is you click on menu, go into normal mode, and then you click on option. And under F4, there's a little button called Calc. So you click on Calc and then head over to F2, which is d of dx. So you click on that. And what you do is, it doesn't differentiate, but you actually put the original function. So I'm going to put down x to the power of 3 minus 4x plus 5. And I'm going to put a little comma to say that that's the end of the equation. And I'm also going to put the 2 in there because that's telling me to find the gradient of this function when x equals to 2. Click on enter, and I'm going to get 8. So a really quick, easy way to check your answer. And this question, of course, is worth an achieved. So did you guys have any issues with that, or can we move on to the next question? Hello, Rishan. Welcome back. Yeah, sorry, had some technical difficulties, but move on to the next question. Move on, move on. Are we moving on? Just waiting for some confirmation from you guys. Yep, no worries, Rishant. Yep, moving on. Cool, second question coming up for you guys. This is also an achieved question. By the way, for the previous question, you had to find both the derivative and gradient, but I think you guys got that. All right, so with this question, I'm going to give you guys, how much time should I give you guys? About 90 seconds. So 8:13, I'll go through the answer. L, are you asking about how do you put in X? Is this for the graphics calculator? Is that what you're asking, L? So if you notice in the graphics calculator, what I've done is, so I write down the function first, so that's the function itself, and then I put a little comma here, and I automatically put 2. Basically, this 2 is saying that I want you to find the gradient of this function when x equals to 2. So that's what that comma 2 is basically for. And once you do that, you press enter. It's actually going to give you the what the gradient is for this function when x equals to 2. So that's how you do it. It's just a nice way to check your answer if you're doing it. Like sometimes it's like you'll be in a rush and then you kind of like miss out the actual question. So that's why it's a good way to check your answers. All right, guys, that's 8:13. So I'm going to go through this question B. As usual, I'll just kind of fly through it and then I'll pause and ask you guys if you guys have any questions that need clarification. Let's get this corrupt. Imogen, if you do just the graphics calculator, you will not get an achieved for it. So you'll have to do both the derivative function and the answer to get the full achieved for that question. So if you just do calculator, and I think that's something that you guys have to realize in calculus, you can't just do graphics calculator answers. So most of the cases you have to show working, apart from a couple of the algebra questions, which we'll talk about next time when we do the algebra papers. Anyway, let's go through question 1B here. So with 1B, what we've got here is we've actually got a gradient function, which is f dash of x, and we've been asked to figure out what f of x is. So this is what the question is asking us, to figure out what f of x is. The other key information that we have is we've actually got this information when x equals to 2, y is equal to 5. So we're going to write this format here. So basically, this is what it means. F of 2 is equal to 5. All right. Now, you don't need to do that f of 2 equal to 5 part. If you understand how to substitute, then that's fine as well. So here's my gradient function, which is 3x squared plus 4x minus 1. Now, I'm going to integrate it, or anti-differentiate as some people like to call it. So I've got 3x squared. I've got to add 1 to the power, divide by the new power, which is 2 plus 1. Then I've got 4x. Now it already has a 1 there. Remember that whenever x is by itself, it has a 1. So I'm adding 1 to the power, divide by the new power. And finally, I've got negative 1. And of course, in this case, it's just going to be x. And of course, don't forget the c. So now I'm going to just simplify this real quickly. Again, you don't need to, but it makes sense. So I've got 3 and 3 in the denominator, so both of them are going to cancel out. And I'm left over with x to the power of 3, plus I've got 4 and 2. So 4 divided by 2 is 2. And I'm going to get 2x squared minus x plus c. Now, I need to put the f of 2 is equal to 5. So I'm going to put down 5 is equal to 2 cubed plus 2 squared minus 2 plus c. So what I've got here is 5 equals 8 plus 8 minus 2 plus c. This gives me 5, and this gives me 16 minus 2 is 14. What have we got? Just want to make sure that I'm on the right track here. Otherwise, sometimes I will make silly mistakes like this. And then I can kind of rewrite this as c is equal to 5, take away 14, c is equal to negative 9. So my f of x, or my equation of the function, is x cubed plus 2x squared minus x minus 9. Now this question is worth an achieved. In terms of what you needed to do is you actually need to get, let me just see if this is going to work or not. So you guys can have a look here. This is the answer schedule. You actually need to show both antiderivative, so the integration part of it, and f of x. F of x is not required, but the c negative 9 is also accepted there. So that's something that you guys need to kind of do for the final question. All right, so let's come back to the stream here. Mitchell, when is the next Algebra Live? Have a look at my website. Have a look at Instagram. I think my schedule is posted. I think it's posted in a couple of grapevines and local grapevines as well. Why does f of 2 equals to 5? Okay, so think about it like this, right? F of x, so f of x is the same thing as saying y. So if you think about it like this, you know how a point can have x, y? To find y, what we do is we put x in the equation to find y. And that's pretty much what this is. So the point could also be written as x and f of x. Because what it really means is that f of x and y is pretty much the same thing. So when I actually put down f of 2 equals to 5, the point here is 2, 5. So x is equal to, when x equals to 2, y is equal to 5. So the way we write it in f notation is we write it like f of 2 is equal to 5. Cool. If you guys are okay with that, do we have any more questions on that one? Otherwise, we can move into question 1C. Yep, no worries, somebody. Might just leave that notes up there, but cool. Are we ready to move on to the next question, guys? Yep, that's one yep. That's good enough for me. Okay, so next question here. Yeah, I'm just going to leave it up here for you guys. And this one, I'm going to give you guys about 3 minutes to have a go. So, well, 2.5 minutes. I'll start going through it, the answer at 8:22. Bananas, well, there's a whole lot. Maybe I should do a video for that, man. Running is awesome, man. Like, get some good tracks, good music, chuck it on, go early in the morning. Mm, must have felt like no, I'm not gonna lie, man. Like, I think I was running for different reasons last year. It was more to do with my own mental health than physical. It was nothing to do with physical. It was just trying to do something to get over something and not get over something, but to accept something. And yeah, running for me is different. I run because it makes me feel good. I don't like run to make look good or anything like that. DT is the same as S of T. Yes, it is. Yep. Whoa. Hang on. In this case, it's not. In this case, it's not Daisy Gee because S of T normally is to do with kinematics. Um, I don't think we're actually doing kinematics in this case because you can actually see the D is depth. And you like this thinking, schools, South Africa. No. Wow, okay. I'm trying to recognize your name, Kanye, but Maquis, not in this case because that's for kinematics. When you think about V of T stands for velocity. So we're not actually looking for velocity or distance in this case. What we're looking for is depth and to find the greatest depth that she reaches. Oh, yeah. Actually, I do remember. Yeah, yeah, that was in term one holidays, right? Because I was down there in term one holidays and I remember meeting a teacher there. That was a conference. So, all right, it's 8:22. Yeah, it's 8:22. Let's actually go through this answer here. And I'll actually talk you guys through it as well. All right, guys. So with this question, what we've got here is we've got a diver that's going into pool. It's actually the depth that she reaches. T after she hits the water is given by blah, 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 this equation. Find the greatest depth that she reaches. Okay. So the first kind of idea that you guys have to realize here is I always like to have a look at the equation that's given. And then once I have the equation that's given, then I can kind of go, oh, okay, I think I got an idea of what's happening. So if you think about it, have a look at this equation here. It is a positive t squared minus 4t, which means it's a parabola and it's a positive parabola. So it's going to look something like this. So if you imagine it, like I can't believe I'm doing this, but like it kind of helps you guys answer the question. So this is the pool right here, right? And so the D is the depth. So this is the depth that we're looking at. And we are basically trying to figure out what's this point right here, when she reaches as low as possible. So really what we're trying to do is we've got a parabola and we're trying to figure out at what point is the turning point actually happening. So basically that means differentiate, put it equal to 0, and you're done. So d of t is 1.25 t squared minus 4t, which means d dash of t, which is the differentiated function, is going to be 1.25 times 2, which is 2.5t minus 4. All right. Now what we can actually say is d dash of t is equal to 0. And you can write it like this for turning point. And so we're going to put 0 is equal to 2.5t minus 4. And then we need to rearrange. So we've got 4 is equal to 2.5t. Unless I've made a mistake somewhere. I'm trying to see. No mistake so far. So then I need to figure out what t is. So t is equal to 4 divided by 2.5, which means t is equal to, what is it? 4 divided by 2.5 is going to give me 1.6. Now this is really important, this part here. The t is actually stands for time. And if you think about it, the question is actually asking for the greatest depth. So the greatest depth happens when t is equal to 1.6. So in other words, we want to actually figure out what is the depth at 1.6. Now in the previous video, a couple of videos ago, I did f of 2 equals to 5. In this case, I'm going to put down d of 1.6 because I want to know what's the depth at 1.6 seconds. So I got to go back to the original equation and I've got to substitute 1.6 wherever t is. And once I do that, then it's just a matter of just putting it all in the calculator, multiplied by 1.6 squared minus 4 times 1.6. So that's going to give me negative 3.2. All right. Now, think about it like this. Negative 3.2, it's the reason it's negative 3.2 is because the ground level is 0. That means when you go below the ground level, that's why your answer is actually at a negative. So you're just going to write down that greatest depth is 3.2 meters. All right, so grades wise, what we're looking at for this is derivative found and equated to 0 or t equals to 1.6. All of that gets you achieved. So basically, getting a 1.6 gets you an achieved, or putting this equation and antiderivative and function found. No, hang on, I'm looking derivative found and equated to 0. So you got to do this up to here. So up to the first green line gets you an achieved, or getting the 1.6 gets you an achieved. But if you do the final answer of 3.2, you're going to end up with a merit. Time for minimum and depth found. Yep, that's pretty much how you do question 1C. All right, I come to you guys here. Uh, 1.6. No, you guys got it. How did you t equals 4 over 2.5? That's just a rearranging, because remember, like I could actually do it like this. So because 2.5 t is equal to 4, t is equal to 4 divided by 2.5. That's all I did. Yeah, no, Makis, it does say negative 3.2. Like and I think this is a 2014 paper. I always like to give a little sentence towards the end. Um, well, it's kind of like Kanye. If you think Kanye. If you think about it, zero is ground level, right? So negative 3.2 means it's below ground level. And we can almost say that if you think about it like a pool, um, like the start of the pool could be considered as ground level. Therefore, when you go down the pool, you're going to actually end up with negative answer because you're actually going below ground level. Cool, guys. Are we ready to move to the next question? If there's any more questions, just chuck it up on the chat. Otherwise, we can move on to the next one. Yep, we're moving to the next one. Is there a way any okay, next question, guys. I'm gonna give you guys how many times? It's a turning point at 3, 4 gradient. Yep, I'm gonna give you guys about 4 minutes for this. All right, so have a go at this. And again, remember, this is a merit question. So even if you kind of like go through some part of the question, you could potentially get an achieve for it. So have a go at this, and then we'll go through the answer at 8:34. No, 3. Yeah, 8:33:50, something like that. Banana Swirl, I'm just reading through your comment because it's quite. Is there any way that you can limit the jump from L2 mats? If I know a few of the guys that are doing level 3 this year, they pretty much ended up watching all the calculus videos, and there's a couple of series that I did towards the middle of lockdown last year, which I think I had like a couple of year 12 sitting year 13 complex numbers after watching through that sitting through that series. So yeah, it is possible that you can actually kind of get through that. No worries, Franklin. Just trying to do my bit to help out people, man. So glad you're enjoying it. There you go. Which one are you watching, Georgina? Is it the 2014 edition? Ah, 2019 paper, yeah. Cotton Slayer. Why does that name ring a bell? Nice, nice. Good stuff. Mm, interesting answers you guys are popping up with. There you go. We're starting to kind of get some answers there. That's cool to see. And again, guys, don't get disheartened if you get an answer wrong, because as I, this is something that me and my son, we talk a lot about. We make mistakes, so we learn from them. All right. So if you do make a mistake here, make a mistake with these questions, then just go back to your working, have a look at where you made that mistake. All right. It is a great learning opportunity right now. Um, so if you find that, damn, these other guys are getting like -2 and I'm getting like something different, then go back and have a look at your working because that process there helps you much, much more than me kind of going through and explaining everything. All right, so you got to try and figure out where you made that mistake because that actually helps you with the learning. Anyway, that's 8:30, 3:30. Let's go with this question. I got to remember to record. Otherwise, I have to do some too much editing after this. But anyway, here we go. Where is it? I need to look away from the chat so that I don't get distracted. All right, guys, so the way we're going to break down question 1D is we've got a graph, which is f of x, so that's fine. So and again, this is another strategy that I use, is that I actually write down everything that I have got. So I know that this is the graph that I've got. It says that it has a turning point at 3, 4, and this is a really important piece of information, all right? So the first piece of information that's quite important is the turning point at 3, 4. Because it's 3, 4, I can actually rewrite this as f of 3 is equal to 4. Because remember that when x is equal to 3, y is equal to 4. So this is what the green part that I've actually highlighted. That's the first key point. The second key point that I'm going to look at is it says that it is a turning point. A turning point happens when the gradient is actually equal to 0. So that means I know that f dash of 3, so that's like the gradient function. So if I take the gradient function and I substitute 3 in it, I'm actually going to get 0 because that's the gradient at 3 equals to 0. So that's what that yellow part literally means. All right. And now, finally, I'm going to go down to the question itself. The question is asking for the gradient when x is equal to 4. So what is the question actually asking? The question is asking what is the gradient when x equals to 4. So this is what I'm actually looking for. So with that in mind, I've got to work through the process very, very slowly. So there's quite a few ways that we could potentially do this. We can actually figure out what k is first, and then differentiate it and put it equal to 0, and then solve it. Hang on a minute. Let me just check, can I do that? Has a turning point at 3, 4. Yeah, so why wouldn't I just do why would I do that method? That's like so hard. I'm just looking at it and I'm like, there's a couple of ways of doing this. So why don't I just, okay, let me just try this. I might have to re-record this, but that's fine. Cool, so I'm going to slightly do a different variation of this because I'm looking at the point 3, 4. So this is one way of doing it, right? Like because I've got f of 3 equals to 4, I'm going to use this to actually figure out what k is. Because if f of 3 is equal to 4, then I can say that 4 equals to minus 3 squared plus k times 3 minus 5. Then I'm going to get 4 minus 9 plus 3k minus 5. Is that right so far? I hope it's right. I'm going to get minus 14. So I've got 4 is equal to minus 14 plus 3k. Rearrange the 14 to the left-hand side. I'm going to get 4 plus 14, which means I've got 3k equals 4 plus 14. 18 equals to 3k, which means I can say that k is equal to 6. It's kind of weird. I'm doing a completely different way, but it's still going to work, I reckon, because f of x is then equal to negative x squared plus 6x minus 5. Then I need to differentiate it. So when I differentiate it, I'm going to get negative 2x plus 6. And I'm looking for the f dash of 4. So f dash of 4 is just going to be negative 2 times 4 plus 6, which is equal to negative 2. Now, it's really weird because it's like in this particular question, I've not used the turning point at all because when they gave me the point 3, 4, I kind of skipped through it. Now, you guys might have done it completely different, and I'm going to show you guys the second method. So the second method, what you could have done is because you had f of x is negative x squared plus kx minus 5, you differentiate it. When you differentiate it, you're going to get negative 2x plus k. And then we use the yellow box because gradient at 3 is equal to 0. So we're going to put 0 equals negative 2 times 3 plus k, and we're going to get 0 equals 6 plus k, and k is equal to 6. Then we can find f dash of 4, because we know that f dash of x now is equal to negative 2x plus 6, because this is basically from here. I got it from here. And then I can actually go f dash of 4 equals negative 2 times 4 plus 6. And once again, I'm going to get negative 2. So as you guys can see, there's actually two ways of doing this particular question. And both of them are going to end up with the same answer. Grades-wise, negative 2 gets you a merit. Derivative found and 6 found gets you an achieved. So you've got to do this and this, both of these to get achieved. So for achieved, you need to find k equals to 6 and find out when what the gradient function is as well. Yeah, so interesting little question in terms of two ways of doing this. But yeah, that's basically it for 1D. All right, let's have a look how bad the chat is. I'm trying to see. Oh, I made a mistake. Yep, I see where the mistake is. Yep. I know where the mistake is. Sorry, there's a mistake here. This should be negative 6 right here. Negative 2 times 3 should be negative 6. It's the rush job. Yeah, sorry, Eric, I made a mistake. That should have been negative 2 times 3, which is negative 6. Tiny mistake. Kind of like thinking ahead. Anyway, any questions with that particular question, guys? Because I know it was a bit of a, there's two ways to do it, but if you guys are happy with that, we can move on to the next question. Storm Buddy, just a bit of a heads up for you. If you do want to catch up on the notes, have a look at the description of this particular stream. There's a link to the OneNote, and you can, if you go into the OneNote, just click on right at the top. You got exam papers. Go right down to level 2 calculus. It's a live document. It'll probably take like about a couple of minutes to sync up, but all those notes will be there for you guys. All right, so we're going to the next question, folks. That's not fun, man. Okay, so question E. Question E is it is an excellence question, guys. And how do I put this? If you've been like attending like my level 1 tutorials for algebra, and if you've been attending some of the level 2 algebra tutorials, I guarantee you that if this type of question comes, you should be thanking the Lords, because this is going to be one of the most easiest excellence question that you're going to attempt. But I'm going to give you guys kind of like a few minutes to get started, and then I'll start going through it at about 8:45. Yeah, there you go, McKees. Free E7 right there. Daisy is not from Linfield College, is it? Yeah, I thought so. Yeah, I know who you're talking about. I was, you know, if I know, like I sent him an email before, but if you do see him, just say that I was really humbled by his response, and it was just yeah, it was a little yeah, it was just awesome to hear something like that from somebody like that. So really appreciate the words that he actually sent me. So if you do see him next time, just say massive thank you to him from me. Uh, you know, Kanya, I have to be honest with you. Before I did, before 2012, I loved probability. I loved statistics, and even though I was trained fully in calculus, I loved statistics. But somewhere along the way, I started doing the algebra and calculus, and I don't know. It's just I think that people have told me that the way in which I explain it kind of makes sense to them, and I kind of just started focusing on that, and there we go. Nah, Kaita, I'm not part of any because I teach at an intermediate school now. So because I teach at an intermediate school, I don't get access to any of the papers. I don't even know what's happening with the NCAA world. These tutorials are run just for the yeah, just to help out people. That's it. Nice. We're starting to see some answers here. That's pretty cool. Uh, oh, that's hmm, okay. Shape of graph is accepted as well. No, it's not a waste of talent, man. I love what I'm doing at my school right now. Like, absolutely, the amount of things that I've learned in the last 1.5 years, stepping away from NCEA maths, it's just like I'm constantly looking to learn new things. The only reason I'm still doing the tutorials in the nighttime and the videos in the nighttime is just to keep in touch with, well, to keep in touch with the maths itself. Nah, Hayden, I only teach one class of maths. The rest of the time, I'm like mucking around in a makerspace, playing around with laser cutters and things like that. Yeah, no worries, Kaita. Just if you do know people that don't know about this channel, just send the link to them. Um, Hopefully it helps them out during this time. All right, guys, look, that's enough talk. Let's actually get to this question. Um, as I said to you, the free E7, as I call it, sometimes I call some excellence questions just good, good bit of what do you call it? Easy E questions. All right, so I'm going to switch away from chat for a second while I go through this question, and then I'll come back to chat. Um, all right, so let's hit this record button here. So question 1E, what we've got here is we've got a function, and we want to figure out for what values of x is this function decreasing. Now notice how they've actually said to you, you must use calculus to finding your solution. The reason is because you can actually do this question in the calculator, and you can kind of see what's actually happening. So first off, I'm actually going to show you guys how to do this in the calculator, but please don't just write the answer for this question from the calculator, because if you do that, you're not even going to get achieved for it. So the way you do it is you go into graph mode and you put in this freaking annoying long graph. 2x cubed over 3 plus 3x squared over 2 minus 20x plus 4. So we put this in graph mode. We click on draw, and currently you can't really see this graph, all right? Because I mean, like, and trust me, your calculators are going to be a lot more slower than this one here. But basically, the graph is going to look like a positive cubic. So this is what I'm talking about. That's a positive cubic. So it's going to look like this. And what else do we have? We've got the X and Y axis like this, right? So what you can do is you can click on Gsolve and notice how there's like a max and a min. So if you click on maximum point, the maximum point is when X equals to -4. So this is your maximum point, which is -4. And then if you click on Gsolve, you click on the minimum point, and you can see the minimum point is actually 2.5, positive 2.5, which is that. Now, okay, there's the answer right there in front of you. Because if you look at it, for what values of this graph actually decreasing, you can see that it's actually decreasing between these two values here. And yeah, that's the answer right there. But unfortunately, as you can see, this line here, it says you must use calculus to find your solution. But here's the trick. You already know what the answer is. So that means you just got to figure out how to get to the right steps to get to this part. All right. So what we're going to do, I'm going to leave everything up here for now. I guess the first step is like for decreasing. Remember that for decreasing, it is less than 0. And on the side here, I'll actually put it down as well. G dash of x is greater than 0 for increasing. G dash of x is less than 0 for decreasing. This part right here is worth remembering because that's just something that you just gotta have to kind of do. So I'm gonna work out what G dash of x is. So G dash of x is 2x cubed over 3, so that is just 2x squared. What have we got? Plus 3x minus 20. So that's what my G dash of x is. Now I know that for decreasing function, and this is what I'm going to do. This is like, I'm still doing all the work for decreasing function. I'm going to get 2x squared plus 3x minus 20 is less than 0. Now, I would strongly recommend you guys to actually have the both graphs in this case. So I've done the top graph, which is the final answer. So I kind of did that at the top right there. But now this equation here should be very familiar for you guys because you would have done this in level 1. You would have done this in level 2 algebra for discriminants. So basically, we're trying to figure out when is this quadratic less than 0. So what we need to do is we need to actually factorize it. And again, this part, you guys can actually use the calculator. You don't need to actually do the quadratic formula or anything like that. So what do? You go straight into graphics calculator, go to the equation mode, go to polynomial, which is F2, click on degree 2, that's, because it's x squared, and then chuck in your values, which is 2, 3, and -20. Put that all in, click on solve. So there's my 2 points, which is 2.5 and -4. So we can kind of say that x is equal to 2.5 and -4. But really, the reason why we have those two values is because we are now going to draw the gradient function. So that's the 2x squared plus 3x minus 20. It looks like this. And we're trying to figure out when is this graph less than 0. So for it to be less than 0, it's between here and here. And we also know what these 2 points are, which is -4 and 2.5. And if you guys look at the top here, we already know what that answer is, and we've just proven it here, but we're going to still have that diagram in there. So we can just write a little statement somewhere like this. G of x is decreasing when you have x is between -4 and positive 2.5. All right, as you can see, like in level 1, you guys had to do a lot more work because you had to actually factorize and then you had to put it in the graph. But in calculus of this particular paper, you can actually use the calculator to get those little values. So therefore, you know when to, as long as you prove to that, you're all good to go. So grades wise, region correctly identified and justified using one of the methods. And I'm going to talk to you guys about that very quickly. That gets you an excellence. Derivative found in the G dash of x may be implied. So that is somewhere here. You could potentially get a merit. Oh no, that's actually, sorry, this part is what derivative find and the x values of turning point. So that's this part here. And then getting up to this line, is actually going to get you an achieve. So as I said to you, this was one of those quite an easy excellence question. And you should be kind of thanking the gods if you do find one of these kind of decreasing, increasing function questions. Okay, so that's basically it for this question. We go to the next one. How are we going on the chat here? Laser cut maths equations. Trust me, I'm actually doing a design at the moment with a parabola lamp. I'm still working on it. So it's basically like taking a whole bunch of parabolas, putting it together to try and get a graph. Actually, hang on, I forgot to show you guys one other thing. By the way, one other thing is right here, which is the answer schedule. So if you guys have a look here, their working is pretty much very similar to what we did. So they've actually figured out what the gradient function is. They put it equal to 0. They found the 2 points. And here you see they've actually got two different methods. So what we decided to do was we actually went with shape of graph of a positive cubic. That's what we went with. So that's what they mean by justifying use one of the methods, or can be in words as well. All right, so it is a really nice excellence question. But again, it's how much you actually understand in terms of what's happening with the cubic and the parabola. Okay, let's go back here. Where are we at? Where are we at? Where are we at? Oh, sorry, Jennifer, I kind of like went through a little bit fast with that, but they just gets canceled out. But I'll just put that up here as well. Sorry, I know I kind of went through that real quickly. So g dash of x is equal to 3 times 2x squared over 3 plus 2 times 3x over 2 minus 20. So that's where the they canceled out. Hopefully that made sense there. That one step I kind of missed through. Daisy, the diagrams are not imperative, but it does help. I would say it does help the marker in the sense where they can kind of go, actually, this kid knows what they're talking about, not just randomly doing stuff. But I always suggest that I remember even in the algebra MCAT paper, I suggested to people like, draw the diagram like how I did with the parabola at the bottom there, so the marker can actually understand. Makise, you could do double derivative as well, but that means you still have to compare like 2 or 3 points. Actually, there should be some graph paper that you can actually ask for in the exam paper, or they also have like extra back pages actually tend to have like grid paper that you can play around with as well. Yeah, so as I was talking before to Daisy, Suhaib, it's highly recommended because it helps you visualize what the question's actually asking. Any more questions from you guys for this? Nah, yeah, just do a small figure. Yeah, that's what I would say, Strivix. Like you don't need to do like a massive accurate drawing. Like a good quick sketch is more than enough. Like none of these graphs are accurate. I mean, I'm just drawing like a rough sketch here just to understand what's happening with the cubic. We got one more excellence question coming up, guys. Are we ready for it, or what are we doing? Okay. Good old kinematics. All right, guys, this is going to be the last question for today. And what I might do is I might just record the other two questions later on some point, and then I'll upload it for you guys so you guys can just watch the whole thing from the beginning. Currently play or played is the question. Both. Oh man, I used to play everything when I was a kid. Like even before starting work. What do I do? Actually, wait, how much time am I going to give you guys first? Let's say 8:58. So I'll start going through this answer at 9:04. 9:04. Yeah, 6 minutes to nice 6 minutes for you guys to try and do this question. Is minimum speed 0? We don't know. Um, Daisy, in this case, his minimum speed, we don't know what his minimum speed is. I just looked through the answers for this question. I'm going to say to you guys actually don't need 6 minutes for this. I'd say probably less than that. 4 minutes, you'll be fine. So think about it like this, Daisy. I think I'll just give you a bit of a clue, right? So S of t is a cubic. So this is S of t. Because it's a cubic, it's going to look like this. Velocity of this function, a cubic, actually differentiates to become a parabola. And the question is actually asking for minimum speed. So they're actually asking for this point right here. Hopefully that made some sense. That's the hint I'm going to give you guys for this question, if you haven't started it yet. And by the way, if you have not started this question, at least differentiate. Because if you differentiate, you are most likely going to get an achieve just for differentiating the function. Am I correct? Yes, you are correct. I'm absolutely, yeah, I am, because I just checked the answer schedule. Even if you don't know how to start a kinematics question, if they've given you like a distance function, differentiate it. If they give you acceleration or velocity function, depending on the question, you could integrate it. No, extinction never. I could never get into Fortnite, man. I tried it so many times, and I was just like, this is just, I don't know. I just couldn't get into it, man. But in terms of sports, I played football, I played badminton, I played basketball, indoor cricket, outdoor cricket, squash, badminton, touch rugby. Uh, yeah, I did quite a few things. God, I'm sorry, Eric. Like I think I still haven't got the graphics card to figure out a way to connect my PlayStation to the PC. It's the minimum 4.98 meters per second. Let's have a look, Suhaib. I think you need to read the whole part of the question. You guys are going to get frustrated with the answer. I can tell you this right now. From the old school guys, I really like. I mean, when I first started watching, I actually watched Jordan's final shot, which was on TV. That was really cool. That was the first time I really got into basketball. Then I ended up. Oh, well, you're definitely onto something here, Daisy. But read the question again, Daisy. Read the question again, particularly this part here. Yeah, game 6 against the Jazz. And then I think in early 2001, I started following the Timberwolves for a while with Kevin Garnett. That was good fun. All right, guys, another 30 seconds and I'll go through this answer for this question. Current player, I don't know, man. Like I really struggle with the current crop of players. Um, like I like the players for different reasons. Like to be honest, I absolutely respect the hell out of LeBron for the work that he actually does outside of basketball. Like I love the school that he opened in Akron, I think it is, the I Promise School, which is just a phenomenal idea. And then I look at someone like Giannis, his work ethic and his humility. It's like that's really cool to see in this age. Yeah, so I mean, like, there's different players that have different things that I like them for. They set good role models. All right, I'm going to go through this question here, folks. So, as usual, we're just going to kind of like rub these things out and we're going to start from the beginning. All right, guys, so with question F, what we've got here is, what do we've got? We've got S of t, which is a cubic function, and t is time, blah, 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 and they're passing a fixed point. Okay, so this fixed point keeps coming back. I guess if you think about it like this, if you were to draw this, right, the fixed point is when t is equal to 0. So that's what we're going to say this fixed point as, the starting point. The question then says how far, so this is the thing, how far will the cyclist be from the fixed point when he reaches minimum speed? So if you think about it like this, when the question is actually asking for how far, we're actually looking for S of t, all right? But the thing is, we don't know what that time is. The only thing we know is that time is when the velocity is a minimum. Now remember that if you want to figure out when is the velocity minimum, you've actually got to find out what acceleration is, and you got to put it equal to 0. Because when you think about it like this, for velocity to be maximum or minimum, acceleration has to equal to 0. So this question, we've got S of t, and I'm just going to write it all down. I might have to read. Can you guys hear the fireworks in the background, or just me? I do apologize about that. Well, I can't really do anything, but that is what it is. Cool. So we've got S of t. So we got to figure out what the velocity function is. So that means I'm going to differentiate everything. So I've got 0.1875 times 3. I'm in the wrong mode. 1.1875 times 3. That's going to give me 0.5625 t squared. And then I've got minus 2.25 times 2 is 4.5 t plus 21. Now I got to work out the acceleration formula. So acceleration of t is equal to 0.5625 times 2, which is 1.125 t minus 4.5. Now, remember, the acceleration is equal to 0 when the velocity is a minimum. So I'm going to put down a is equal to 0 for minimum velocity. So 0 is equal to 1.125 t minus 4.5. Kind of have to rearrange this. So I'm going to get positive 4.5 is equal to 1.125 t. And then I can say that t is equal to 4.5 divided by 1.125, which gives me t is actually equal to 4. 4.5 divided by 1.125. There we go, 4. So t is equal to 4. So because t is equal to 4, now all I got to do is I got to work out what S of t is. So what is S of 4? Because at 4 seconds, he is at the minimum speed. So I'm going to substitute 4 in this equation, which is 0.1875, 4 cubed, minus 2.25 4 squared plus 21 times 4 plus 0.5. So once that happens, all I've got to do is just substitute it into the calculator and I can actually get what my answer is. So what do I got? 0.1875 multiplied by 4 cubed, which is 64, minus 2.25 times 16 plus 21 times 4 plus 0.5. Have I done something wrong here? Hang on, let me just check my working again. Yep, thank you. Yep, figured out where my mistake is. It's the, not 24, but 21. There we go, 60.5. Cool. So grades wise, what are we looking at for this one? Distance found, units not required. So straight up excellence for this question right here. Acceleration equation found and set equal to 0. Wow. So you get a merit up to here. For this line right here is you're going to get merit. Actually, I would even go down and I'd put it probably, this line here is going to get you a merit. And then achieved is this line right here. Yeah, so you know, on first looks, it looks pretty kind of ugly and complicated, but really, once you start going through what the question's actually asking you to do, it's not a bad excellence question. Yeah, so that's basically it for question 1F. All right, I'll pop over to the chat. Yep. Is it 12 meters when the cyclist reaches? 60.5 is what we were looking at, guys. Now we got, what do we got? We've got Guy Fawkes coming up as well, right? Rishant, why was, yes, Eric, I wouldn't put it as 61, man. I would put it as 60.5. Why was acceleration set equal to 0? Because minimum speed, velocity, when you're trying to find minimum velocity, your acceleration has to be equal to 0. Thank you. Another mistake. Yep. It did say units not mattered, and so even though I did put meters, I probably would be penalized for it. No, I don't think I will. Probably kilometers is the answer I'm looking for. So Storm Buddy, all I did was like I found out that at t equals to 4, when t is equal to 4, that's like at 4 seconds, that's when he reaches his minimum speed because his acceleration is equal to 0. So then all I got to do is I got to go back to the original distance function, which is right at the top, and I've got to substitute 4 in it to try and figure out what that distance is. So that's all. That's what I'm doing in the last part right there. Cool, guys. Any other questions with this particular question? Yeah, kinematics, I know that I did a video before, but I just can't remember. It's in one of the Calculus Live tutorials. Uh, Yeah, retaliation. This is a 2014 exam paper. So hey, basically just a bit of a hint here. So when you actually have S, V, and A, to go this way, you have to differentiate. And then if you're going backwards, you've got to integrate or anti-differentiate. Let me see if I can find that link for you guys. Give me a second. I just, for the life of me, I can't remember when I did it, but let me just have a look. 2020 whiteboard. When did we do it last year? Okay, that does not look like kinematics. Here we go. Here we go. This whole tutorial is dedicated to kinematics. So that would be the tutorial I ran on 19th of August 2020. So how do we find this? Let's go find this. Okay, so calculus tutorials, calculus prep, calculus tutorials. And where are we at? What date was it? 19th. There we go. Kinematics 1. So if you guys go in here, this whole tutorial is just everything to do with kinematics. And I think I spent like nearly, just over an hour on it. And it's covering pretty much all the achieve merit excellence types of questions in it. All right, so I'll drop the link for you guys on, where is it? I can't, here we go. I'll put the link here on the chat. That's the kinematics video. Go have a look. That should pretty much cover everything you need to know for kinematics. Cool, guys. Look, I'm basically that's all for today's session. So what will happen next is I'm just going to have a look at when our next scheduled tutorial day is. What is it? Yeah. When do I see you guys next? Today, Tuesday. So I guess I see you guys next week, Monday. Yep, that's when I see you guys next week, Monday for algebra, and then we see you again on the following Wednesday. Yeah, I'm kind of trying to keep it even between all of us at the moment. Good fun as always. Cool, guys. All the lives, they get recorded and they'll be uploaded within like a minute of once I stop the tutorials. So yeah, I will catch you guys next week sometime. Till then, stay safe. Have a good one, and I will, as always, just hang around in the chat for a few minutes if you do have any final questions. Otherwise, have a good one. I'll catch you guys next time.